Dr. M.A. Bhagaveni, Professor, Department of Electronics and Communication Engineering, College of Engineering Gindi, Anna University, Chennai. Dr. M.A. Bhagaveni graduated from Government College of Technology, Coimbatore, has completed her Masters and PhD at College of Engineering Gindi, Anna University. Her field of interest includes cognitive radio, ad-hoc networks, wireless sensor networks, and wireless communication. She has completed 2 projects, one for CVRDE and the other for DST. She is the recipient of Young Scientist Award from DST. She has got 2 Best Research Paper awards in international conferences. She has published more than 70 research papers in reputable journals and conferences. She is author of 2 books. The one is Analog and Digital Communication and the other is Cognitive Radio, an Enabler of Internet of Things.
Welcome to UGC lecture series on BSc Electronics Honors Practicals. This session we are going to see about amplitude modulation. In this we will be covering the contents like what is modulation, types of modulation, amplitude modulation. First we look at what is called as what is modulation. In the present era we need to transmit signals from one place to the other. Like any information that is generated need to be communicated to the destination user. For example, we may create new signals or we may want to send some information like emails, or we want to just convey the person who is sitting beside us just that some novel informations, like we want to say that what you had today. It is also an information, right. So, what color dress you are going to wear, like this any human being will be willing to communicate with another human being. Like that the persons may be available near you or he may be available very far away from you. So, in that case your signal need to be communicated through systems. So, the system that helps you to communicate is nothing but a communication system. In communication system, we will be transmitting the signal of our interest through the communication system to the receiver. So, if we are going to have a communication system will generally have a transmitter, a channel and a receiver. The transmitter just modifies the signal suitable for transmission over the noisy channel. Okay. So, at the receiver the noisy signals will be received and they will be corrected in order that it can be clearly seen or clearly heard. So, the purpose of the receiver is to receive the signals properly. The purpose of the transmitter is to modify it in such a way that it will be communicated properly over the noisy channels. So, at the transmitter we have one of the process of the transmitter is modulation. The purpose of a communication system is to transmit the signal from the information source to the destination. So, to do this the transmitter modifies the message into a form suitable for communication over the channel. This modification process is called as modulation. The modulation can be achieved by means of varying some parameters of the carrier wave in accordance with the message signal amplitude. So, now you will be clear what is called as modulation. Modulation is achieved by means of varying some parameters of the carrier wave. So, now maybe you may not be clear what is called as a carrier wave or what is a message signal, but still a modulation is achieved by means of varying some parameters of the carrier wave in accordance with the message signal amplitude. Okay. So, we will see what is a modulation. The modulating signal is nothing but the baseband signal or the information signal, while the carrier is a high frequency sinusoidal signal. So, we have in the modulation process 2 signals. One signal is the modulating signal, the other signal is the carrier signal. Okay. The modulating signal will be nothing but the baseband signal or the information signal. Baseband signal is nothing but a voice, right. The voice will be between 0 to 3 kilohertz. We can speak, any human can speak or emit some signals between 0 to 3 kilohertz. A human here can hear the signals between 20 hertz to 20 kilohertz. So, these are the frequencies generally created by human beings in the environment. Similarly, it can be a chip of the bird, right, music. Like that, every signal as it generated in the environment, it will be called as a baseband signal. So, this baseband signal is the information. This information need to be carried over by the communication system to the receiver end. So, that is done by means of using a carrier. A carrier is nothing but a high frequency sinusoidal signal. So, in modulation process, the parameters of the carrier wave, the parameters are nothing but the amplitude, the frequency or phase. So, any signal can be mathematically represented as with some amplitude A signal is represented with some amplitude A cos of omega c into t. So, right. So, A will be called as the amplitude of the signal, omega c is nothing but 2 pi f c, where f is the frequency of the signal, and we may add up some phase difference to the signal as plus psi or theta. This psi is nothing but the phase of the signal. So, this is your carrier signal C of t. You can write a signal C of t as A cos omega c t plus psi. A is the amplitude of the signal, f c is the frequency of the signal, and psi is the phase of the signal. In modulation process, what we are going to do is, we are going to either change the amplitude, change the frequency or phase. We can change either amplitude, can change either frequency or phase with respect to the amplitude of the message signal. So, how we are changing A with respect to the amplitude of the message signal? When we are going to change the frequency of the carrier with respect to the amplitude of the message signal, it is called as frequency modulation. When you are going to change the amplitude of the carrier with respect to the amplitude of the message signal, it will be called as amplitude modulation. If we are going to change the phase of the carrier with respect to the amplitude of the message signal, then it will be called as phase modulation. So, a modulation purpose in general will be doing some changes to the carrier wave in accordance with the modulating signal. This modulated signal is then transmitted by the transmitter. Is it okay? So, why we need to change? We have certain advantages by changing it, right. Just see that we can first, we have transmitted the signal. At the receiver end, we need to demodulate the received signal and get the original information signal back. So, as you have modulated or changed the characteristics of the transmitted signal, at the receiver end, removing such characteristics is called as demodulation. This demodulation will be exact opposite to the modulation process. So, in the process of modulation, the carrier wave actually acts as a carrier which carries the information signal from the transmitter to the receiver. We are going in for modulation for it has certain advantages, right. So, in the process of modulation, the baseband signal is translated, that is shifted from low frequency to a high frequency. This frequency shift is proportional to the frequency of the carrier. So, we are going to change the amplitude of the carrier signal with respect to the amplitude of the message signal. So, finally, the modulated signal will be at a frequency of the carrier signal. So, this results in the translation of frequency from the baseband to a higher frequency level. A modulation has many advantages. One of the advantages is that it gives reduction in the height of the antenna. How? We will see in your next slide. we can see how our modulation process is going to reduce the height of the antenna. It has another advantage, it avoids mixing of the signals. As it goes to a higher frequency, it can also avoid mixing of signals. Like it is possible to multiplex many signals by moving each signal to a different frequency ranges. It also increases the range of the communication. So, a normal baseband signal cannot be communicated over a longer range, but once it is get translated to a higher frequency range, it can be communicated over a long range distance. It also improves the quality of reception. So, with this set of advantages, we are doing any purpose with certain advantages, right. So, we go in for modulation purpose because of all these advantages. Let us see what will be the height of antenna, how the reduction in the height of antenna is achieved. In general, for the transmission of radio signals, the antenna height is a multiple of lambda by 4. If you want an antenna, you are going to design an antenna to transmit signal with wavelength lambda, the height of the antenna should be at least lambda by 4. So, when we use this concept, the lambda is nothing but speed of the light c divided by frequency of the radio wave. C is the velocity of the light and f is the frequency of the signal that we are going to transmit. So, to get a lambda of our signal, what we are interested to transmit, to get the lambda, we should do speed of light divided by frequency of operation, we get the lambda of our signal. So, once we get the lambda of the signal, to compute the height of the antenna required, right, divide the lambda by 4, then it will say that is the height of the antenna you need in order to transmit this particular frequency signal. Okay. As an example, the minimum height of an antenna required to transmit a baseband signal of 10 kilohertz, we get a value of 75,000 meters. 10 kilohertz is your frequency. So, f will be equal to 10 kilohertz. So, lambda will be equal to c divided by f, this part is f, right. Lambda by 4 will be c divided by 4 times f, the answer will be 7500 meters. So, you can just think of how high the antenna is. But once we are going to modulate the signal, baseband signal to a higher frequency, that is from 10 kilohertz to 1 megahertz, right, the minimum height of the antenna with this modulated signal, we get c divided by 4 times f. Now, f has become 10 into 10 power 6. So, the height is only 75 meters. So, this is 7.5 kilometers, this is only 75 meters. So, as we go higher up in the frequencies, the antenna height will keep on reducing. So, this is an obvious good advantage of your modulation system. Next, we can also see it avoids mixing of signals while going in for modulation purpose. If the baseband sound signals are transmitted without using modulation by more than one transmitter, then all the signals will be in the same frequency range. Either sound signal that can be heard is between 20 to 20 kilohertz. So, if all the transmitters are transmitting our voice 0 to 3 kilohertz, right, there are 2 or 3 transmitters, what happens? All the signals will get mixed and nothing can be received at the receiver. While doing modulation, we can separate out each transmitter signal by fixing up different carrier frequencies for each transmitter, and hence each transmitter will be transmitting the baseband signal at different frequencies. So, we will not have any mixing of the signals. So, we can avoid mixing of signals by going in for the modulation process. Next obvious advantage of modulation is increasing the range of communication, increasing the range, that is covering a larger area. The frequency of the baseband signal is always low, and the low frequency signals, they cannot travel longer distance when they are transmitted, they get heavily attenuated. So, the attenuation reduces with increase in the frequency of the transmitted signal and they travel longer distance. So, the modulation process naturally it increases the frequency of the signal being transmitted, therefore, it increases the range of communication. So, the range here is nothing but the distance between the transmitter and the receiver. How long your signal can be intelligibly heard at a distant place is the range of transmission. So, once you go for modulation, your range also increases because attenuation decreases with respect to the frequency employed. Next advantage of modulation is you can do multiplexing. First, I will just explain what is multiplexing. Multiplexing is a process in which two or more signals can be transmitted over the same communication channel simultaneously. You can transmit two or more signals over the same communication channel simultaneously. This can be achieved only by the process of modulation. The multiplexing allows same channels to be used by many signals. Many TV channels can use the same frequency range without getting mixed with each other, or different frequency signals can be transmitted at the same time. So, we have two types of multiplexing, one is called time division multiplexing, other is called frequency division multiplexing. So, with respect to modulation, we are indirectly achieving frequency division multiplexing. So, if you are assuming user 1, user 2, user 3, all the users signals are within voice communication, that is 0 to 3 kilohertz, user 2 is also 0 to 3 kilohertz, user 3 is also 0 to 3 kilohertz, but the carrier used for user 1 is 1 kilohertz, carrier used for user 2 is 10 kilohertz, carrier used for user 3 is 100 kilohertz, then obviously all the user signals are multiplexed in the frequency domain and they can be transmitted over the same channel. So, there is one more advantage of multiplexing, you can transmit or use the same resource for different signals. And also there is an added advantage of modulation is nothing but improved quality of reception. The effect of noise reduces to a greater extent when we go for higher frequencies compared to lower frequencies. Noise usually attenuates the amplitude of the signal. If it is of low frequency, more noise is added to the signal. If it is of higher frequency, the amount of noise added get reduced, and therefore, the quality of reception also improves as we do modulation process. So, in nutshell, modulation is something good for transmitting a signal from the transmitter to a receiver. So, there are various types of modulation, continuous wave modulation and digital modulation concepts. In this class, it is meant only for amplitude modulation. So, the amplitude modulation falls under continuous wave. There are another continuous wave modulation technique, that is your angle modulation technique. It has two more divisions over that is frequency modulation and phase modulation. In this session, we are going to see only about the amplitude modulation concepts. In modulation, the characteristics of a carrier signal is changed based on the information that we wish to transmit. So, the information what we wish to transmit will be called as a modulating signal. The signal that carries the information is called as the carrier signal, and the output of the modulator is called modulated signal. Okay. So, that we will be able to change either the amplitude, phase or frequency with respect to the amplitude of the message signal. In that case, if we change the amplitude of the carrier, we will be getting AM. If we are going to change the phase of the carrier, we will be getting phase modulation. If we are going to change the frequency of the carrier, we will be getting frequency modulation. So, these are the three types of continuous wave modulation techniques. An overall block diagram of the AM modulator will be, you will be having a AM modulator, to that a message signal and a carrier signal will be given. At the modulator, the signal gets modified, in the sense the amplitude of the carrier will be changed with respect to the amplitude of the message, and what you get as output is nothing but the AM modulated signal. So, this is a block diagram representation of AM modulation. So, you will be having modulator which takes in two inputs and gives you one output. The process of varying the amplitude of the carrier wave with respect to the modulating signal is called as amplitude modulation. So, let us assume the carrier signal C of t to be AC cos 2 pi f c t, where AC is the amplitude of the signal, peak to peak amplitude of the signal, f c is the frequency of the signal, t is the time scale. You can just view this as a carrier signal. The carrier signal's amplitude, frequency or phase is going to be changed to get a modulated signal. Let m of t be the modulating signal or the message signal. This is your m of t. We already told that message signal will be of low frequency, carrier signal will be of higher frequency. So, you can see this is your message signal. You can represent the message signal as AM cos omega m t, where AM is the amplitude of the message, Fm is the frequency of the message and t is over the time axis. So, let m of t be a modulating signal, C of t will be the carrier signal, the amplitude modulated signal S of t will be AC, the amplitude of the carrier is getting modified by the message signal. So, it is 1 plus K A m of t cos of 2 pi f c t, where K A is nothing but a constant which is nothing but the amplitude sensitivity of the modulator. When we say amplitude sensitivity of the modulator, we mean that how sensitive the modulator device is. So, if we are going to give 1 volt, if the modulator will recognize that and produces 1.2 volt, that is called as the sensitivity of the device, how sensitive the signal is. Okay. So, that parameter is your K A here. This is nothing but the amplitude sensitivity of the modulator, how sensitive, how the output is changed with respect to the input value. So, the amplitude modulated signal S of t is nothing but the amplitude AC, amplitude is getting changed with respect to your modulating signal. In diagrammatic form, we have given to the modulator a carrier wave which is of higher frequency, then a message signal which is of lower frequency. When you look at the signal in the CRO, you are going to see a signal like this, a signal like this. Is it okay? Now, where is your message? Where is your message? You can see the signal is just moves as the carrier frequency, but the amplitude of the carrier is changing with respect to the amplitude of the message. Okay, you see the envelope of the signal, it is just the envelope of the message signal whatever you have given. So, the modulator has changed the envelope or the amplitude of the carrier with respect to the amplitude of the message signal. So, this is a high frequency signal. At the amplitude level or the envelope level lies your message. This is your AM modulated signal. For this AM modulated signal, the message signal is available at the amplitude of the carrier wave. So, this is a AM modulated signal. So, you can see the signal at the lab. This is a typical example of a AM modulator, where we will be giving an input signal, this is a message signal, and a oscillator to produce a high frequency carrier signal. A multiplier will produce, it is nothing but a AM modulator, this will produce a AM modulated waveform. So, you should not think that it should be always, the message should be always a sine wave. So, that is why I took the slide to just to say that your message can be of any signal type, still your modulator will produce a AM modulated waveform with respect to the amplitude of the message signal, right. So, you can see the amplitude is getting changed with respect to the amplitude of the message. This is your AM modulation. In this, we will be measuring certain parameters like what is the maximum value of the modulated signal. The signal is the AM modulated signal. We will be measuring what is the maximum value of your modulated signal, that is called as E max. So, you should measure E max from this point to this point, it is not up to this end, it is not peak to peak. E max will be between the time axis line and the height of the maximum voltage value of the signal. that will be called as E max. Then E min will be from the base to the minimum most value that it has produced, that will be E min. So, from the envelope we will be taking up two measurements, one is E max, the other is E min. So, whether we can definitely get the modulated signal for all types of signals, for all types of message signals. So, that is what whether the envelope S of t will maintain the shape of the m of t. It will maintain only if certain conditions are satisfied. Conditions are the amplitude Ka into m of t. Ka is the sensitivity factor of the modulator and m of t is the message signal amplitude, right. Ka into m of t should be less than unity. Otherwise, what we get something called as over modulation. This results that the absolute value of Ka m of t multiplied by 100, we get percentage of modulation. It is also called as modulation index. And one more concept, the carrier frequency f c must greater than the highest frequency component of the message signal. So, you need to satisfy two conditions in order to see that AM modulation happens. One of the condition is the sensitivity of the modulator and the amplitude together should be less than 1 and the highest frequency component in your message signal should be very much less than the FC, the carrier frequency. Is it okay? So, when you satisfy these conditions, you see W is the message frequency, highest frequency of your message signal, FC is the carrier frequency of your carrier. This FC should be much larger than your message signal highest frequency, then AM modulation happens. We go in for Fourier transform of the AM wave in order to see that how much bandwidth it is going to occupy. So, you want to transmit a message, it is having a highest frequency value of W. Once you AM modulate it, amplitude modulate it, what will happen to the bandwidth? So, to do that we do transforms to the signals. So, when we apply Fourier transforms, what we get is nothing but the spectrum of the AM wave. Fourier transform of the signal S of t we have already wrote in the previous slide. If we take the Fourier transform of S of t, then it will be called as S of f. This S of f will be equal to AC by 2, AC is the amplitude of the carrier value divided by 2 times delta function del of f minus f c plus del of f minus f c plus Ka AC by 2 m of f minus f c plus m of f plus f c. So, when you plot this spectrum, this is your message signal. This message signal we are going to see the bandwidth occupied by this. So, we are plotting with respect to frequency what is the amplitudes of the message signal. It is just one W, 0 to W, this is a baseband signal. We have taken up a signal of bandwidth W. This is a negative axis representation, this is needed for communication purpose, right. We just see why we are not just covering only the positive axis of your frequency, even the negative axis of the frequency is also important. So, that is why it is symmetrically repeated over your negative axis. The signal occupies a bandwidth of 0 to W, it is been repeated over the negative axis to have this part. So, that is your minus W. So, a bandwidth of 0 to W is the message signal that we have taken up. This is your message signal Fourier transform. When you take Fourier transform of AM modulated signal, this is what you are going to get. We will see what is the output waveforms. This after AM modulation, your spectrum waveform will be as equation we have seen, it is AC by 2 del of f minus f c, this part, AC by 2 del of f plus f c, that is your this part. So, what had happened? The baseband signal at the center, now it has got shifted to the center frequency plus f c with f c plus W and f c minus W. Now, the bandwidth is occupied by the AM modulated signal will be Fc plus W and Fc minus W. This is for the negative axis of the spectrum. The amplitude of the carriers are half Ka AC m of 0. K is the sensitivity, AC is the amplitude of the carrier signal, message signal amplitude. Okay. So, this is how your bandwidth or the spectrum of AM signal you will be getting it. Okay. This part of this is called as upper sideband. Between Fc to Fc plus W we call it as upper sideband. Between Fc to Fc minus W we are going to call it as lower sideband. The center line is nothing but the carrier Fc. So, AM modulated signal will have Fc, an lower sideband and an upper sideband. It is repeated over the negative frequency axis. Based on this, the AM modulated signals are classified into many types like single sideband modulation, double sideband modulation, double sideband suppressed carrier modulation, etc. So, that is why I just want to show you or see what will be the spectrum of a AM modulated signal. Now, as a result of the modulation process, the spectrum of the message signal m of t for the negative frequencies extending from minus W to 0 become completely visible for measurable frequencies, provided the carrier frequency satisfies the condition that Fc is very much greater than W. You can just think of if Fc is less than W, Fc is less than W, we will be having overlapping of the spectrums. So, the important idea of negative frequency is you will be having upper sideband separately and lower sideband separately, otherwise they will be getting overlapped with one message and the following message. So, the transmission bandwidth for the AM modulated signal, which will include upper sideband, lower sideband and the center carrier frequency, totally it is going to occupy a bandwidth of 2 times the W. When it is in the base band, we would have used a bandwidth of only W, but by going in for AM modulation, the bandwidth is improved or enhanced to an amount of 2 times the W. So, with respect to this, we have seen today what is modulation, what are the advantages of modulation, what are the different types of modulation, like we have seen types of modulation like AM, FM and PM. Out of all these types, we have just discussed only one type of modulation called as AM modulator. Was the principle of operation of AM modulation, how we are going to provide carrier signal and message signal, how the nonlinear device is going to produce your output, what is the frequency response of the AM signal, that is nothing but Fourier transform of the AM. Once you take the Fourier transform of the AM signal, you will be getting upper sideband, lower sideband in the positive frequency band as well as in the negative frequency band. So, how the spectrum of the AM modulation will look like. In general, the signals are over a band of frequencies. So, this band of frequencies will occupy a band in the upper, band in the lower. So, that is why it has been drawn as a triangle, that is what we have seen. With some questions class today, you can answer these questions like what is modulation, what are the advantages of modulation. Now, you can define what is AM. AM is amplitude modulation. The amplitude of the carrier is varied with respect to the amplitude of the message. Such modulation is called as amplitude modulation. Thank you.